Okay, section 4 is special products. So there's just a few special ones. You can kind of recognize them right off the bat when you're factoring them. The first one is called a perfect square trinomial. So this is going to be when there's 3 terms. Okay, and when you look at the terms and you go to factor them, you're going to notice that the 2 factors are the same. Okay, so this is a monic trinomial. I put an S in both my parentheses, and I say, what multiplies to 36 and adds to 12? And we go through our factors, and we get 6 and 6. And they're the same. When they're the same, we write it like this. S plus 6 squared. Okay, so that is a perfect square trinomial. You can recognize them by factoring it and noticing the factors are the same, or the first term and the last term are both perfect squares. And then we can go through and check. So S plus 6 times S plus 6. So S times S is S squared. S times 6, 6S. 6 times S, 6S. 6 times 6, 36. Our middle terms give us that 12S. So we multiply back to the original problem. So the more you factor these, the more you'll start to notice when you look at the numbers. So when I look at my next one, I say, oh, look, 144 is a perfect square. So is C squared. What's the square root of 144? 12. What's 12 plus 12? 24. So you say this is C plus 12 squared. C plus 12, C plus 12. Was that a plus or a minus, actually? Okay. If it were minus, it would just be minus 12. So if it were C squared minus 24C plus 144, it would just be C minus 12. Negative 12 minus 12, negative 24, negative 12 times negative 12, positive 144. Okay, this next one is called the difference of squares, not sum, it's just difference. You're not going to have it work with sum. Okay, now in this case, it's going to start off as a binomial. So there's only 2 terms, and they're both perfect squares. Okay, so notice that they're both perfect squares here. D squared minus 36. Middle term's missing. Fill it in with a 0D, just this time till you get used to seeing them. So when you're looking at that, you say, okay, well, what multiplies to 36, negative 36, but adds to 0? Six minus 6, right? So it's the same number, except they're different. So multiplies to negative 36, adds to 0. D plus 6, D minus 6. So this difference of squares is you have 2 perfect squares. The middle term has been canceled out. So it's the same factor with just different signs. So if I check that, say we check that, we have D plus 6, D minus 6. We go D times D, D squared. D times negative 6, negative 6D. 6 times D, positive 6D. 6 times negative 6, negative 36. Negative 6D plus 6D cancels out. That's where you get that D squared minus 36. So I look at my next one. It's only 2 terms. There's a minus sign, and they're both perfect squares. What's the square root of 169? If you don't know it off the top of your head, you can always check in your calculator. 13. Yeah, so we go x plus 13, x minus 13. 13 minus 13 will make the middle terms cancel out. And then if I multiply them, I'll get the 169. Now, sometimes with these, there might be a number in front. So let's say I added this and it was like, I added maybe a 25 in front. And there might be one at the back too. So maybe like this. Still the same thing. They're all perfect squares. So it's the same factor, just one of them's plus, one of them's minus. So we just take the square root there. That would be 5a plus 6b, 5a minus 6b. Just take the square root of each of those. Square root of a squared is a, b squared b, square roots of 25 and 36. Okay, so with these, just recognize the difference. Perfect square trinomial has 3 terms. It's in the form ax squared plus, I think it goes 2ab, something like that, plus, yeah, it's plus or minus 2ab plus c, and then x, yeah, like that. There's the form. I'm trying to remember that. Anyway, it's 3 terms, and there's perfect squares. That's how you'll notice. And then difference of squares is just ax squared minus c squared. They're both perfect squares. So 2 terms, 3 terms, 2 terms. All right, the next one is a little bit harder to recognize and follow. Not to recognize, but just to follow, because you have to follow this special formula here. So this is sum or difference of cubes. So to recognize it, you're going to see a cube. So something cubed, x cubed, a cubed, b cubed, some letter being cubed. They're going to be perfect cubes, so you want to remember that list of the ones I gave you. Remember, it was 8 for 2 cubed, 3 cubed was 27, 4 cubed 64, 5 cubed 125, 6 216, and 7 343. That should be most of them. So you recognize those as well. When you see those together, either plus or minus, then you're going to follow this format. So you have to follow this format here to do them for factoring. So you're going to find a and b, and then it's a plus or minus b, then a squared plus or minus ab plus b squared. Now, the way that you would follow this, there is actually an acronym to help you remember it. It is SOAP. Like that, where that stands for same sign as what you started with. So same sign. O is opposite sign. And then AP is always positive. So same, opposite, always positive. So for example, we have x cubed minus 64. Okay, so find the cube root of a and b. So a would be x cubed, b would be 64. So for a, you would find the cube root of x cubed, which is just x. And for b, you're going to find the cube root of 64, which is what? That's just 4. Okay, so you have a is x, b is 4. So it's a, so x, minus b, so 4. And we already have the signs here, so same sign minus. Then a squared, so x squared. Then ab, so x times 4 is 4x. And then 4 squared. and then simplify whatever you need to there. So that would be x minus 4, and then x squared plus 4x plus 16. Okay, notice that looks like it's a perfect square trinomial, but it's not, because that doesn't add. We can't find a factor there. So this last thing here, that's prime. Can't factor this. And that's why it works. So let's look at x cubed plus 27. So we find a. It's going to be the cube root of x cubed, which is x. B, cube root of 27. What's the cube root of 27? 3. Okay, so we go a and b, and I'm going to put the signs in at the end. A squared, so x squared. Then ab, so x times 3, 3x. Then b squared, 3 squared is 9. And then same sign, so plus, opposite sign, always positive. So x plus 3, x squared minus 3x plus 9. If you want to check it, you can multiply it out. Okay, then we have 2 more examples. Okay, so you have 8x cubed minus 216. We should notice those from our list. So a is going to be the cube root of 8x cubed. What's the cube root of 8? 2. Yeah, so 2x there. And then b, what's the cube root of 216? That's not 4. It's what cubed? Cube root 216. 6. All right, so in our parentheses, you have your a, and you have your b, and then it's a squared. So when you do a squared, you're going to have to do this, 2x, and then squared, like that, because we're going to have to fix it. And then ab, so then it's 2x times 6, and then b squared. I'm out of room. Like that. So 2x and 6. Then a squared is 2 squared, x squared. So that is 4x squared. Then 2x times 6 gives me 12x. And then 6 squared gives me 36. And then same sign, opposite sign, always positive. So this would be my factorization. Now, I know you can take a GCF out of that second one, but because this is a special factor, you're not going to. Any questions? You guys want to try this last one on your own? Same exact way you just did this one. Yeah. Okay. So let's take a look. So for A, we have the cube root of 125x cubed. What'd you guys get? Good. 5x. And then for B, cube root of 343 y cubed. What do we get there? 7y. Good. Okay, so we set this up. So we have A and B, so 5x, 7y. Okay, then it's a squared, so it's 5x squared, then ab, so 5x, 7y. and then b squared, 7y squared. All right, so 5x, 7y. So we want to square this. So that's 5 squared x squared. So this should be 25 x squared. 5x times 7y. 5 times 7 will give us 35. And xy. Then 7y squared is 7 squared y squared. So that should be a 49 y squared. And then SOAP. So same sign. So plus, opposite sign. So that's minus. And then that's always positive. And that should be our answer.